So this is Conics Check In number 1. So in number 1, they said the center is in the second quadrant somewhere here. The radius is 3, and it's tangent to the y-axis at the point 0, 4. So let's see. Let's draw 0, 4. 1, 2, 3, 4. So the center is somewhere here in the second quadrant, and the radius is 3, and it's tangent to the y-axis here. So it must be doing this. So if the radius is 3, I'm going to go 1, 2, 3 units right here. So my center is going to be -3, 4. And then it's going to go out 3 units in every direction. 1, 2, 3, 1, 2, 3, 1, 2, 3. So here's my circle. And I really just want the equation. So that's going to be x plus 3 squared plus y minus 4 squared is equal to the radius squared. And since the radius is equal to 3, that makes it 9. All right, and then for the second one, this would have been your homework quiz. So, yep, already printed it. So we've got our original equation right here. So let's see, we know we've got y squared and just x's. So this is going to be an x equals y squared parabola. This is going to be like a left-right parabola. And what I'm going to do with my y is I'm going to want to complete the square. So I'm going to leave my y squared plus 6y on the left-hand side, leave a little room. And then I'll subtract the 8x and add the 7 on the other side. And then we're going to complete the square here. So let's see, I want to add, take 6, cut it in half and square it. That gives me 9. Add that to both sides. And then we'll factor this side. That is y plus 3 quantity squared equals -8x plus 7 and 9 is 16. And then we'll keep writing it in the correct format here by factoring a -8 out of there. So notice that'd be -8 times x minus 2. That minus kind of messed people up. And I've still got my y plus 3 quantity squared here. And then we'll divide both sides by -8 to make it -1/8 times y plus 3 squared equals x minus 2. So we said we're looking at a left-right parabola. This is a negative, so I know it's going to be a left opening kind of parabola. So now we can start taking a look at everything that we know. So we've got the vertex here would be 2, -3. So we can start giving ourselves a little picture over here, 2, -1, 2, 3. We said this parabola is going to open to the left. And we need to know how far to go for the focus, which will be inside the parabola, and the directrix, which will be over here. We got to figure out the p-value. So we got that -1/8 is 1 over 4p. So p must be -2. So I'm going to go 2 units this way, and that's going to give me the focus. So my focus is 0, -3. I'm going to go 2 units in the other direction. This is going to be my directrix. So there's my directrix. So that's a line. That equation is x equals 4. Notice directrix is a whole line. It's not coordinates. So give us the equation of a line. And then let's do that focal diameter idea here. So we know we've got the vertex right here. Here's the focus. The focal diameter is 4p in length from top to bottom. So I'm going to start here at the focus, and I'm going to go 2p up and 2p units down to get the ends of the focal diameter. So I'm going to go, let's see, p is 2, so I'm going to go up 2p, that's 4 units, 1, 2, 3, 4. And then down 4 units, 1, 2, 3, 4. And those will be on my parabola. So those 2 points kind of help us shape the parabola correctly. So, all right, we said those endpoints of the focal diameter were this point right here, 0, 1, and this point down here, 0, -7. And then we could put the axis of symmetry in. We've got our axis of symmetry going straight down the middle of the parabola, and that is also a line, y equals -3. All right, hope that made sense.